The worst AI agent planning failure I debugged last quarter looked successful for almost an hour. A coding agent was asked to inspect an issue, edit 3 files, update tests, and summarize the fix in one pass. The final message was confident. The diff was plausible. The tests even looked related. But production still failed, because the agent misunderstood the bug in the first 10 minutes, and every later action built on that mistake. There was no clean checkpoint, no proof of the diagnosis. We had to replay the whole run by hand. Naive agent planning treats the model like a junior engineer who can hold a whole project in working memory and execute a mini waterfall plan. Analyze the repo, make the change, write tests, fix failures, update docs, and report back. That feels efficient because it reduces loop overhead. In practice, it bundles too many assumptions into one action. If the final result is wrong, you do not know whether the plan was bad, the tool call failed, the file edit drifted, or the verification was skipped. Big bang steps create unfindable failures. The agent may have worked hard, but effort is not progress. In a reliable loop, progress means a verified state change you can point to. The pattern is simple and opinionated. Each iteration should aim for exactly one verifiable outcome. Not one vague task, not one paragraph of intentions. One outcome you can check. Find the failing test, identify the relevant file, apply one patch, confirm the test changed from red to green. After that, replan. Plans are cheap. Bad assumptions are expensive. The loop's power is not that the first plan is perfect. The power is iteration. Plan small, act small, verify often, and let confirmed progress compound. This is slower per step and usually faster per completed job. Mechanically, I structure the loop around 4 fields: state, next action, verifier, and evidence. State is what the system believes right now, with sources or prior checks attached. Next action is a single operation. Read one file, run one query, edit one function, ask one clarifying question. The verifier is chosen before the action runs. That matters. If you choose the check afterward, the agent can rationalize. Evidence is the observed result: command output, diff summary, citation, test result, or explicit failure. Then the controller updates state and asks, based on this evidence, what is the next single step? Take a coding agent assigned to fix a date parsing bug. The big plan says inspect, fix, test, commit. The small step loop starts with one outcome: reproduce the bug. The action runs the failing test or creates a minimal reproduction. The verifier checks that the failure is real and captured. Next loop, locate the responsible function. The agent may inspect only the stack trace and one candidate file. Verification is a cited function name and line range, not a hunch. Next loop, patch one function. Verification is a diff limited to that file. Next loop, run the narrow test. If it passes, replan to run related tests. Each step leaves a trail. If the broad suite fails later, you know exactly which verified state was last trustworthy. Small steps are not magic. You can make them so tiny that the loop burns budget shuffling paper. Read file, think, read next file, think, with no useful state change. You can also use weak verifiers, like asking the same model, did that work? Sometimes that is all you have, but treat it as low confidence. Another failure is state drift. The loop verifies a step, then later summaries distort what was proven. Store evidence, not just prose. The trade-off is overhead. More tool calls, more records, more controller logic. My opinion, pay that cost where failure is expensive, and relax it for low-risk drafting or exploration. This pattern connects to almost every foundation in loop engineering. Stop conditions depend on verified outcomes, otherwise the loop stops because it feels done. State management depends on clean evidence, otherwise yesterday's guess becomes today's fact. Budgets matter because one-step planning can run forever if you do not cap iterations, time, or tool calls. Verification depth is the next dial. Some steps need a deterministic test. Some need a second source. Some need human approval. The point is not to make agents timid. The point is to make the unit of progress small enough that you can trust it. Here is a 10-minute exercise. Open one automation you already have. A research script, a support triage bot, a coding helper, anything. Find the biggest instruction in its prompt or controller. It probably says something like, investigate and resolve, or gather sources and write a retort. Split that into 3 single outcome steps. For each step, write the verifier before the action, What observable result proves the step worked? A file exists, a test passes, a source has a date, a ticket has a category. Then run only 2 iterations and inspect the evidence trail. If you cannot tell what changed, the step is still too big. 3 beats to keep. First, AI agent planning should produce the next verifiable step, not a giant promise. Second, verification belongs after every step, not at the end when the trail is cold. Third, progress is verified evidence in state, not tokens spent, tools called, or a confident final answer. Small steps do add overhead, but they localize failure, make retries cheaper, and give your controller something real to reason from. Tomorrow, we keep building the foundation layer of reliable loops. New loop engineering episode daily on this channel. Build loops that finish, verify, and stop.